Yeah, since I'm discussing more about classification algorithms or classifying models, classification models or many classifiers. So there are some classifiers I have shown in this slide which are available there. For example, perceptron, which is nothing but artificial neural network, naive Bayes, decision tree, and very important machine learning algorithm which gives us prediction, regression problem also, as well as classification from the branch like a tree. We have a logistic regression for two variable problem. We have a k nearest neighbor for clustering or unsupervised learning. We have artificial neural network as which gives rise to deep learning, very important in machine learning. We also have support vector machines and some ansible methods. So we'll discuss few of them in give an overview about few of them, not in detail. So it's important to mention that classifiers or classification based algorithms, they give us different results at different times. If we compare them with linear models, as I said earlier, linear models gives us same output for a given data again and again, while as machine learning models, irrespective of classification or regression, they can give us different results. Why? Because they work on random simulation. When it comes for supervised learning, when we show them the output that you had to learn yourself or you had to train yourself based on the output, so they use random simulation or random number generators. For example, artificial neural networks, they use random weights. Similarly, support vector machines, they also use their own methods. Somehow they have to, these machine learning algorithms, machine learning models, they have to bring the output as desired by us by any means. These are also known as stochastic based models, or they are also known as artificial intelligent models. And that means we can differentiate into two parts. For example, discriminative algorithms are there. I had to bring y equal to x at any cost. Then there's some generative algorithms. So we'll discuss few of them in detail. Now, here's a classifier. We call it perceptron. Perceptron is a concept taken from artificial neural network. The problem is to classify this into two classes, either class x1 or class x2. Here, if you see, I have given here two inputs to this perceptron, and there is a summation in between. Input is xi1 and xi2, and there are weights associated with it, w1 and w2. This yi cap from outside, this is the desired output. This w0 is a weight to it, and our desired output is that it has to classify into two classes, class x1 or class x2. If you know linear regression, you can easily resemble this equation with linear regression, wherein y is independent variable y cap and w0 is your intercept, w1 is and w2 are nothing but slopes. X1 and x2 are independent variables. This can also help us to give us a prediction about future, for example regression problem, and it can also classify, so that the beauty of classifier is that it acts both as a classifier as a regressor. So problem is here only to classify into two classes, class x1 and class x2. So when, as I said, random weights get generated, there is random simulation happening behind. That means in every iteration new weights get generated. Now I have a given data, I have one desired output which I show to the model that you bring the output as desired by us, as desired by me. Initially it may not be correct result. Second time I run it again, iteration wise, so many iterations it may take to solve a problem, and I see that what the results are given by the classifier, I compare it with the original results which I already have, subtract these two and see how much is the difference. So we call it error. So in a machine learning algorithm, any classifier or regressor we take, we always get some error in the beginning, and with the passage of time the error minimizes, it decreases. Needless to say, if the data is more complicated, it has more number of classes, it takes more time to solve a problem, it takes more iterations. These iterations are called epochs in artificial neural networks or deep learning problems.